Welcome to our second part of our lesson on angles greater than 90 degrees in the unit circle 5.4. It might not be exactly the titles of the sections, so it is still section 5.3, 5.4 of your textbook. Now, I'm actually going to kind of skip this one, just to show, but it is kind of done here. And here is why I'm trying to share with you what a unit circle is. And we're probably not going to finish it today, but I think it's going to make some aha moments for a lot of you. We have the Cartesian plane now, and honestly, the questions that we've actually been doing for warm-up from section 5.1, they've all been actually located in this first quadrant. And to illustrate what I'm talking about, if we put 0 degrees here, in fact 0 degrees is there, a lot of you understand if I start rotating counterclockwise, like so, that's counterclockwise, this angle from here to here is 90 degrees. Everyone agree? 90 degrees. So we've been dealing with questions only in here because that's what we've been drawing. We've been drawing you scaling right triangles. But if we keep on going with this angle counterclockwise, notice what this angle is. If I go from here to here, this is a straight angle, and that is 180 degrees. Let's see if some people can problem solve, no offense. We start from here and keep on going to this part. What angle should this be? Someone do it? Kai?
270.
Nicely done. It is 270. And finally, this is why Microsoft is amazing. I'm kidding, they're not. We go complete full circle. And what angle is that? Kai again. 360 degrees. This is called the unit circle. So let me show you a typical question. Now you might be confused, and that's okay. But let's just say we have a point 3. Let's try that again. Let's try negative 3, comma 4. Now where is negative 3, comma 4? Negative 3, comma 4, using my red chalk, is maybe over here. Now if you have some graph paper, it's actually easier. So that's point P. And some of you are kind of connecting, wait a second, we've done this in grade 10. It's kind of, not exactly, kind of related to the distance of a line segment from the origin. Kind of, not exactly, but it's the idea there. So let's draw that line that goes to point P from the origin. Now let's just erase this if that's okay. Is that hard? And let's see if we can find this angle. Now visually, some of you said, but Mr. Chen, can I just graph it on a graph paper and take out my protractor? Absolutely, but we want to become armchair mathematicians. We want to use trigonometry to solve this. And some of you said, but Mr. Chen, I don't see the right angle triangle. But there is not one, but 2 right angle triangles. And technically, we only use one of them. In grade 11, I must be adamant, please only use the one right triangle. Don't get me wrong, some of you understand what I'm trying to ask. This question, given this point, find theta. That's what we're asking. Find that bigger angle. And again, it's greater than 90 degrees. So how are we going to construct this right angle triangle? From the people in class, just look here before you copy. And if you're watching from home, pause the video and see if you can draw it yourself. Again, if you have a graph paper, way to go. But we're always going to make a right angle triangle with the x-axis. Always. If you really want to know why we do not go with the y-axis, you will learn that in grade 12. Okay, and it'll mess you up. Just believe me. Okay, so although technically you can solve this with the y-axis, please don't. There is a reason. It will mess you up. It's not saying you're not creative. I'm not trying to stifle anything, but I'm just trying to show you. It'll make your life immensely difficult. So before we finish this off for today, and I'll let you guys try to figure this out, there are a few things we have to talk about. There is some notation that some students need to see before we can go further. And this is actually found further in your textbook, but I'm going to talk about it now because it doesn't make sense. If I go from the origin to this right side, This is technically called the initial arm. And it's always what we're going to be doing in grade 11 now. Now in physics class, they change it up on you with your bearings. In physics, they might use like east, south, west, or whatever, 13 degrees or whatever bearings. And they change it up on you. But for us, thank goodness, this initial arm is always going towards the right. Okay, it's always going to go towards the right. I know it seems silly. It's just what's called standard position. That's what I'm really teaching you. This red arm, this is called the terminal arm. Okay? So that's the angle that we want, from the initial arm to that terminal arm. And notice what direction we went, make it counterclockwise. Now there's some more subtle things I want to do, but I think you'll be okay if when we created our right angle triangle, let's now label the sides with numbers. Let's do the easy side. What's this length from here to here? Anybody in the class? It's really easy. No pressure. It's really easy. Tom? 4. It is 4. Nicely done. It is 4. And I'm going to tell you honestly, I am tricking all of you. What is this length? Be careful. Be careful. Because we're no longer with numbers. I am tricking you. I'm tricky. Adam! 3. So I always get the answer. It is the magnitude of 3, but 3 is over here. Everyone see what I'm showing you now? Try again, Adam. What's this length there?
-3.
-3. Now I'm going to teach you this way, and I will still teach you another way if you need help. So that's -3. What's this length? Anyone actually want to know how to solve that longest side? And I'll write it in green again. Can anyone actually solve it? Mental math. -3 all squared, 4 squared, 25 square root of 25. Adam?
5.
It is 5. And technically it's plus or minus 5, but hypotenuses are always positive. This is a famous triangle, but it's not a Hall of Famer triangle. This is a famous 3, 4, 5 triangle. It's a Pythagorean triple. Last part of this lesson. Notice, although I really want to find this large angle, I can solve for this angle. And they use the letter like so, and hopefully that pink pops up on the screen. They use the angle this. And what is this? It looks like the letter B, right? Everyone agree? But this is not B. This is the Greek letter beta, and it's defined as the related acute angle. Let's help out some people with some definitions. Does anyone actually remember what acute means? What does acute mean? Mr. Chen, you're acute. I know, I agree. No, it's not a big tough crowd. Claire?
Less than 90 degrees.
So it's in between 0 and 90 degrees. It's correct. Can't be equal to 90 degrees, it has to be less than, right? So less than 90 degrees is usually what most students say, right? That's 0 to 90. That's what this means. And visually, it looks it, right? So my question to the class, and we'll stop it here. Do you think, and I know some of you are asking questions, but do you think you can solve, first of all, for the related acute angle first, and then solve for the actual angle second? And the reason why I think you can do this, and I'll just tell the class and the people at home, once you find the related acute angle, you actually understand that this angle that I'm tracing with my hand is a straight angle, or 180 degrees. But the actual answer is not 180 degrees, it's a little less than 180 degrees. So I think a lot of you know what you're going to do. And here's the answer what most of you are going to do. Once you solve for the related acute angle, you'll subtract that from 180. And that will give you this angle. Now there's some more subtleties that we need to talk about, but I'll talk about this a little bit later because this is your first exposure to angles greater than 90 degrees and this idea, and I haven't gone to, called the unit circle. This is called a unit circle because technically we can do that, and we'll talk more about that later. Anyways, I'm going to pause the video.